Okay, hello everyone. I am going to go through a Pure Math 1 paper with you today. So this is the February-March 2023 paper 1-2 for Pure Maths 1. So my students have asked me to solve a paper while I am giving all my mental notes out loud, just to see if they can pick up my thinking. So that's the goal for today. I don't know if this is a good or bad idea. I'm going to try and do the paper as quickly as possible, but also giving as much information as possible. So I've got some tea here and I've got some chocolate. I've got a calculator. I have opened up the memo on the screen just to make sure that I'm getting the right answers as I go. I don't want to use the memo to get any information, but just to make sure that I'm not leading you astray. And that's it. Let's see. I've also got my clock here. So this is now, it's now 9:15 at night. This is what I do for fun. Okay. And the paper is 1 hour and 50 minutes. So that's almost 2 hours. So if I just think, so it's 20 to 9, so 20 to 10, 20 to 11. So at about 11, not 20 to 11, 10:30, I should be done. So I don't know, I don't want to take any responsibility for this, but let's give it our best go. And yeah, I hope that it's helpful for you as well. Okay, so what we've got here is question number 1, a line and a curve. Okay, immediately I'm thinking discriminant question from quadratics. Okay, they say k is a constant, show that the line and the curve meet for all values of k. Right, that's an interesting word. So normally you would have to say your discriminant is equal to naught, greater than naught, or less than naught. Okay, if it's less than naught, there's no points of intersection. If it's equal to naught, there's 1 point. And if it's greater than naught, there's 2 points. Okay, so in this case, we need to show that the discriminant is greater than or equal to, because whether it hits once or twice, it's still in contact. So that is the first trick that I can see to this. The other one is they say show that. So they're not asking you to make or find the values for which it is going to intersect. They're saying show that it always intersects. All right, so what we do is we get our curve and our lines. So we're going to start with a simultaneous equation. Okay, I always write my curve on the right-hand side, so my squared value is positive. X squared minus kx minus 3x plus 2 plus 2k is equal to 0. All right, now I want to collect my like terms. I'm always going to have a positive. It doesn't really matter for the b term, but if it was any other term, it does actually matter. Okay, so just my a is 1, my b is minus k minus 3, and my c is 2 plus 2k. So now I'm going to look, what is my discriminant? Okay, I'm not going to make it equal to something. I'm going to see if I can prove that it's always greater than or equal to naught. It's b squared minus 4 times a and c. Okay, if I multiply out my bracket, my squared bracket, I'm going to end up with k squared plus 6k plus 9 minus 8 minus, immediately I'm thinking, don't get the signs wrong, minus 8k. All right. If I add up these like terms, I've got my k squared minus 2k plus 1. Okay. And then my next thing, if I ever want to prove that something is positive or negative, the best way to do that is to go into completed square format. Okay, so I'm going to complete the square here. So I halve my k term, and then I subtract, always subtract whatever the term is squared, and keep your leftovers. Okay, in this case, I've got k minus 1 squared minus 1 plus 1, and so I end up with k minus 1 squared. Okay, now what you need to know about a bracket squared, the reason I go to this point is because it doesn't matter what my value for k is, this bracket is never going to be negative. It's either going to be 0 or it's going to be positive. Okay, so it's a squared bracket. So even if k is minus 100 minus 1 squared becomes a positive number. But there is a special case. If k is equal to 1, then this bracket could also be 0. So basically, I just have to get it in completed square format, and I can say, therefore, my discriminant is greater than or equal to 0. Therefore, the line and curve always meet. Yeah, they meet for all values of k. Alright, so the trick is just understanding that it could be greater than or equal to, and then how one of our best strategies to do that is to complete the square. Alright. Okay, next question. So I'm seeing functions. Immediately when I look at this, I see functions, and I see the keyword transformations. Okay, so my function is defined by f of x, which is x squared minus 2x plus 5, and it's valued for all x's, all values of x. A sequence of transformations is applied in the following order to the graph. So you're first going to stretch it parallel to the x-axis. Anything that happens to x is actually the inverse, well, the opposite of what you would normally do. So if it's stretched by half, it basically means it's squished by 2. Okay, a reflection in the y-axis. So all my y values, well, all my x values are becoming negative because it's going across the x-axis. And then stretch parallel to the y-axis. So that is just my whole function is going to become 3. So I'm changing my x in the first two, and I'm changing my entire function in the last one. All right, now the second, so first of all, you need to know your transformations. Second thing you need to know is that it's easier to work with transformations when the function is in completed square form. Because I can't see here, I wouldn't know what to do if I was to make it go left or right or stretch it. I mean, I suppose I could figure it out, but it's easier just to put it in completed square form. So once again, we're going to halve our coefficient, subtract the square, and we'll have some leftovers, so plus 4. Okay, so this is my f of x function. Now, they want us to put in the sequence of transformations. So the first one is stretch it by a factor of a half. In other words, squish it. So all my x's are becoming 2x's. So literally what I do is, instead of writing an x, that thing becomes a 2x. Okay, that's transformation number 1. So you might want to just put number 1. Number 2 is reflecting it, so all my x's become a negative x. You don't actually want to say it's equal to, because it's not true that it's equal. Okay, so can you see what I did here? I just made all my x's are now negative x. If I were to simplify that, it would just be minus 2x minus 1 squared plus 4. Okay, and then my final one is I'm stretching. So the entire function is stretched by 3. So literally, we have to take the entire function. So I'm going to use a square bracket. And I'm going to stretch the whole thing by 3. Okay, now that's not in the format that they want us to give it in. They want us to give it in ax squared plus bx plus c. Okay, so I'm going to multiply my 3 in. And this is now g of x. So I can actually label this thing g of x. So I'm going to multiply in my 3. And then now I'm going to multiply out my squared bracket. So that becomes 4x squared minus times a minus is a plus. Okay, now I'm going to multiply in my 3. So 12x squared plus 12x plus 3 plus 12. plus 15. Right. And that looks like the correct answer. So note to self, anything that happens to the x kind of looks opposite, and it happens in the bracket. Anything that happens to y happens outside the bracket. Transformations are easier in completed square form. Let me just see for interest. If I did it when it wasn't in that format, so I can make all my x's are now 2x's. So it becomes 2x squared minus 2, that becomes a 2x plus 5, okay? So this is 4x squared minus 4x plus 5. All right, and then all of my x's become negative. So 4 times minus x squared. This actually also works. Okay, so my minus actually there falls away. Okay, and then now I'm taking the entire function and I'm stretching it by 3. I shouldn't say that this is equal. It's not technically equal. And that's not f of x either. Goodness. Okay, this, if I had this 12x squared. So what I'm doing, let me rather write it out twice, is I'm saying the whole function is multiplied by 3. This actually works well as well. So 12x squared plus 12x plus 15. Okay, so if you know what you're doing, changing your x's, changing your y's, you can do it in this way. That keeps it in that format, which is quite simple. So long as you know how to apply each transformation and the fact that all the x's are opposites and all the y's are the actual transformation. All right, next question. A curve has an equation of that. A point is moving along the curve. Okay, that is a typical differentiation rate of change question. So dy dx is equal to dy dt divided by dx dt. That's the formula. It is on your MF19. I don't need to get that out. Okay, find the x coordinate. So I'm looking for a point. X coordinates of a point on the curve where the x and the y coordinates are increasing at the same rate. Okay, so dy dt is equal to dx dt. Okay, so I could write down my formula, dy dx is equal to dy dt, and I'm just going to say divided by another dy dt because they're the same thing. Okay, now to find your dy dx, what do you have to do? You have to differentiate the y in terms of x. So I'm just going to directly do the derivative here. So 2 times 1 over 60. 3x plus 1, I'm going down a power, and then I'm multiplying by the derivative of the inside, is equal to, and then I've got a value divided by the same thing, it's just going to be equal to 1. Okay? So now I've got 6 divided by 60 is 1 over 10 is equal to 1, so if I just multiply my 10 on the other side, I'll have 3x is equal to 9, x is equal to 3. Okay, this is quite straightforward. Maybe something that you're just not used to is the fact that, you know, if they say your dy dt is the same as your dx dt, okay, and then they just can cancel out. If you wanted to make it a variable, so let's just say it's equal to k, and that's equal to k, so in the end we've got k divided by k. The point is that it becomes 1, okay? Okay, next question. The circumference around the trunk of a tree is measured and it's found to be 5. Okay, so that's the full length around. 1 year, after 1 year, the function is measured again and it's found to be 5.02. Okay, so this is in the beginning. That's my U1. And then this is now my U2, which is after 1 year. Okay. Given that the circumference at yearly intervals forms an arithmetic progression, okay? So my D value is going to be 5.02 minus 5. That's 0.02. Find the circumference 20 years after the first measurement. Because we have to be careful because of how they word this question. So 20 years after, so if I just look at the pattern here, my U3 is 2 years. My U4 is 3 years. So after 20 years, I'm going to have a U21. Okay. Just be careful of that. So UN is equal to A plus N minus 1. So I generally find this is tricky when, first of all, like an example like this, and another example is when they talk about the years. So in the year 1995, something happened, and then in the year 1996, something else happened, and then you got to work out how many years later. Always just rather take a bit of time to make sure you're getting the right U and the right N, because those are the trick questions. Okay, so here we got 5, and in this case, we're going to have 20 minus 1. 21 minus 1 is 20D, and that is, oh, sorry, my D is 0.02. Okay, so 5 times 20, no, 5 plus 20 times 0.02, and that brings us to 5.4. Okay, 5.4 looks like the correct answer. Okay, so just watch out. That would be the biggest trick of this whole thing. Okay, now next, it is instead given that the yearly interval forms a geometric progression. Okay, so we still have the same two values. We've still got our 5.02, but now instead of minusing, we are dividing. So 5.02 divided by 5 is 1.004. Find the circumference 20 years after the first measurement. Okay, so we're going to be doing the same thing. So the first one is 5. The second one is 5.02. The third one, okay, and so this is 1 year afterwards, 2 years afterwards, 20 years afterwards, we're going to have 21. So UN is equal to AR n minus 1. That's on your MF19 as well. So 5, and then my ratio is 1.004. And that's basically going to be to the power of 20. So, and what we have here is 5.4. I get 4155, which is 5.42. That is our answer. All right, so I think the trickiest part of this is actually just getting the right year. Okay, the right N value, if I can put it that way. Okay, next question. Point A and B lie on a circle with that as the center. The line AB has that equation. Find the coordinates of B. Okay, what am I going to do? I'm just going to sketch to try and orientate myself because I don't know what they're actually trying to get to here. So let's just see. So I'm going 1, 2, 3, 4, 5, 6, 7. No rulers, so you don't have time for that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So something like that. That's my point A. Point A and B lie on a circle with center -2 and 5. 1, 2, 3, 4, 5. So there's the center of my circle and A lies on it. So I should have a circle with A lying on it. I know that, at least I know where the center of my circle is. Everything else I'm center of right now. Okay. The line AB has an equation. Okay, so we don't know where's B. Okay, so y is equal to -2x. I'm actually seeing -2x plus 26. So I'm just going to, it needs to go through A, and it needs to go through B, and it needs to pass through 26 somewhere up here. Okay, A and B lies in the circle, so basically what I'm doing is I find the coordinates of B. I've got to find the coordinates of B. B is where the line and the circle intersect. So if I can get the equation of the circle and I can do a simultaneous equation with a line, I should get the answers for A and B. Alright, so I don't know why that took me quite a while, but first thing we need to do is we need to find what is the equation of the circle. For an equation of a circle, we need the center point and we need our R value. So we have the center, that's cool. So I can say x plus 2 squared, and then y minus 5 squared is r squared, okay? We can work out our r because we've got a point A. So basically it's the length formula, but you can also just use your circle here. So I'm going to say 7 plus 2 squared, and then 12 minus 5 squared is equal to r squared. So what is that? Okay, so this is basically A1. 12 minus 5 is plus 49. 81 plus 49. Then my R is 11.40, something like that. So 130. Sorry, so my R squared is 130. So my R is root 130. Okay, maybe I'm just going to leave it like that for now. So my circle equation is x plus 2 squared plus y minus 5 squared is equal to 130. Okay, and what I'm going to do is I'm going to plug my equation into y. Okay, because both of those are equal to y. So x plus 2 squared plus, so basically I don't want to make y the subject of my formula for my circle, because that's going to be complicated. So I'm just taking my y and I'm plugging it in. Minus 2x, 26, and then remember the minus 5. Oh dear, my pen has just died. Okay. Let's take a minute to read off my pen and have a okay. Minus 2x plus 26 minus 5. Okay, it's equal to 130. What am I solving for? I'm solving for x. Okay, minus 2x, 26 minus 5. I should be able to do that. Alright, so this is x squared plus 4x plus 4 plus minus 2 times minus 2 is 4. 4x squared. Okay, I'm just doing this on my calculator. Minus 2 times 21 times 2 is minus 84x plus 21 squared. 141 is equal to 130. Okay, let's combine my x's. 5x squared. So 4 minus 84 minus 80x. And then I've got 4 plus 441 minus 130. Okay, I'm just going to divide everything by 5 because that's going to make it a lot simpler. Okay, A divided by 5 is 16x. Alright. Okay, I can see that I can factorize this, but you can also use the quadratic formula if you need to. So I've got my 7 times 9, and they're both the same sign. So x minus 7, x minus 9, so x is equal to 7, or x is equal to 9. Does that make sense? Yes, because A, well, my drawing, I can see is a bit wrong, but my A value is 7, which means my B value must be 9. So, this is not drawn correctly. My A is like that. My B value is 9. So my line probably looks a lot more like much steeper. Okay, something like that. Not okay, nothing is quite to scale here, but it's going to be much deeper. This one is going to be 9. My B value is 9, and that one is 7. Okay, what did they ask for? Find the coordinates of B. Okay, so if B is 9, then I need to work out, and I can basically plug in my straight line. Minus 2 times 9 plus 26. Minus 18 plus 26. Okay, I do encourage you to use a calculator because you don't want to be doing mental maths when you're trying to do other stuff like this. Rather keep your mind working for problem solving and use your calculator for mental maths. But you also don't want to overdo your calculator work. Like if you can see something 1 minus 1, you're wasting time if you put that in your calculator. Okay. All right, so that was the whole of question 5. That's the coordinate geometry question for this. I don't think it's too difficult. It's just orientating. I needed to orientate myself, so work out what are they actually asking me. Oh, okay, if I just get an equation between the line and the circle, I'll be fine. And then to know for a circle, you need a center and you need a radius. Radius is just the length formula. Center, you must use opposite signs. And then just make sure when you multiply out that you do it properly. Okay, don't make silly mistakes. Not worth it. Let me just check the coordinates of B. I haven't really answered this nicely. The coordinates of B are 9 and 8. Okay. Next question. Binomial expansion with something interesting. Okay, so in the expansion of that, because we've got to the power of 7 here, and we've got a lot of x's and a's, it is given that the coefficient of x to the power 4 divided by the coefficient of x is equal to 3. Find the possible values of the constant a. Okay, so I can expect to have more than one value for a. Alright, binomial expansion, I can go straight onto my m23 and grab the formula. I don't have it here, but I think I know it off by heart anyway, hopefully. A over x squared of 7. Okay. Right, binomial expansion. So we first take our a term, a to the power of n plus 7 combination 1, a to the power of 6, and then our b value. Okay, just out of interest, as I'm going, I want to work out what's my final x going to be. That's x7. This is going to be x6. And then divided by x squared, so that's x to the power of 4. So I already have my x to the power of 4 term. I'm also looking at a pattern, 7, 6, 5, 4. So I can expect 3, 2, 1. Okay, so my next term is going to be the one that I also need. So 7, 2, x over a power 5, a over x squared, squared. Right, so those are the 3 terms I can expect. This does continue, so I'm going to put my little dot, dot, dot. All right. And let's simplify. So we've got x to the power of 7 over a to the power of 7. I don't even need that, actually, in hindsight. Anyway, 7 combination 1. I don't know, I'm pretty sure that's just 7. I don't know why I need to do that, but anyway, x6, a6, a over x squared. Nothing too complicated there. 7 combination 2 is 21. x5, a5. And then a squared, and then this becomes x to the power of 4. Right. Now, what are they saying? Okay, I'm just going to simplify this. I'm just going to do a different color pen for now. 7a 6 over a6 x squared. So this becomes 7 x4 over a to the power 5. Okay, just writing these in different color pens. Here we've got 21a squared x 5 over a to the power 5 x power 4. So this becomes 21x, and this becomes a to the power 3. Right, so if I look at what am I doing, I need my coefficient of x to the power 4 divided by coefficient of x. Okay, so I don't want to include my x's because they just said the coefficients. That is equal to 3. Okay, so now I've got a fraction on top of a fraction is equal to 3. So there's different ways that I can solve this. I think the first thing that I'm going to do is I'm going to just flip different times. So I can cancel out a few things. So 7, 14, 21. Okay, so at the bottom I'm left with 3a squared. A is equal to plus or minus a third. That's what I'm getting. Right, cool. So lots of exponents here, but I must say it wasn't too difficult to multiply out the exponents. So just be careful with that. Make sure you do your numerator and your denominator. And then all you're doing is applying what they give you. So the coefficient of x to the power 4 divided by the coefficient of x is equal to 3. Just applying that. My little pink and yellow things here, I always look out for patterns in my binomial expansions to make sure that I'm not making a mistake. It should follow a pattern. Okay, and that's about all the tips that I have for that one. Right, let's keep going. So by first obtaining a quadratic equation in cos. Okay, so we're aiming for a quadratic in cos. Cos squared something plus cos plus a constant. Solve the equation. Alright, so I've got tan theta sine theta is equal to 1. I've only got my identities to work with. We only have 2 identities in pure math 1. So I don't have a cos anywhere here. So I'm just going to start changing what I can. I know that tan is sine over cos. And then that's multiplied by sine is equal to 1. So now I've got sine times sine. So I've got a sine squared. Okay, because they wanted a quadratic in cos, means I don't want sine, so I'm going to turn sine into cos using my identity on your m19. Okay, if I multiply through, this is starting to look like a quadratic in cos. So I'm just going to take all my terms to the right-hand side so that my cos squared theta is positive. Okay, now I've got a quadratic in cos. By first obtaining a quadratic in cos, so just do what they tell you to do. Okay, by first obtaining a quadratic in cos, solve that equation. And we're going between 0 and 360. Alright, so this is kind of like, it is like a quadratic. I need to solve it now. Right, how do I solve this? So, sine squared is 1 minus cos squared. I'm just double checking that I've got everything correct because I'm trying to figure out how to factorize this. I might need to use a quadratic formula. Cos squared theta plus cos squared. Okay, looks like that's the answer, and it looks like I'm going to have to use a quadratic formula. I can't see an obvious way to factorize that unless I'm completely missing something. Okay, I'm not completely missing something. Okay, so put your quadratic equation in. So your answer is 0.61803 or cos theta is equal to minus 1.618. Okay, this one's not going to have any solutions because if I look at my cos graph, and where does it cross 1 minus 1.6? It doesn't. The cos graph only goes down to minus 1. Okay. All right. So, but this one is going to have answers. Let's just check. I always like to give myself a little bit of a sketch. I want to go between 0 and 360 degrees. Okay. And I'm looking at about 0.618. So I can expect to have 2 answers within this interval. Okay, if I then get my inverse function, so inverse cos of 0.618, that's going to give me, oh, make sure you are in degrees. I just get that out in radians. Okay, this gives me theta is 51.8 degrees. Okay, that's the one angle, and now I need to use symmetry to find the other one. So I always get my negative angle, and then I add 360 to it. Okay, so symmetry for cos is always plus or minus the angle, and then the period is 360. So 308, and let me just check. 51.8, 308.2. That's correct. All right, next question. Show that that is equal to that. So here we have a trig identity. We've got to prove it. These are always quite fun. So let's go left-hand side. Right, let me try and talk while I'm going. First thing I'm going to do is find a common denominator. So tan squared theta. I'm sort of wondering, you know, if I should do that or if I should change my tans into sine cos. Either one will work, I assume. As long as the maths is right, anything actually works. Okay, was that helpful is the question. I'm not so sure that was very helpful, but anyway, it's how I started, so I'm going to keep going. Sine squared theta minus sine squared theta. Whenever I do fractions that get a bit messy, I make sure I make a very big line just to know what's on my numerator, what's my denominator. Okay, what I'm going to do now is I'm going to find a common denominator in my numerator. So that's sine squared theta, and then this becomes sine squared theta, cos squared theta, all over cos squared theta, all over sine theta and theta. Okay, I'm still looking at this and thinking that was probably not the best idea, but I'm still just going to keep going. Mathematically, if you do each step correctly, it should work out, but it might not be the most efficient way of getting to something. Okay, so what did I do now? I tipped in time, so that was as if it was over 1. So now I put 1 over sine cos. Now I'm going to take out a sine squared theta because it looks like something that I can do. Cos squared theta. I'm just going for it at the moment. I see another identity here, so that can be changed into a sine squared theta. Okay, as soon as I did that, I can now actually cancel out one of my sine squared thetas. Whether that's what I want to do or not, I'm not sure. Okay, there's a few things that I can see here. So, okay, everything is multiplied here. There's not pluses and minuses. So everything is multiplied. So let me maybe just get all my numerators on the top and all my numerators at the bottom just to show you exactly what. Otherwise, I might just square theta, and that's a sine theta, and that's a tan theta. Okay, So what I can do now is one of my signs at the top can cancel out with that whole sign. So sine 3 theta, cos squared theta, tan theta. Now, sine squared divided by cos squared can become tan squared theta, but I'm still left with one of the signs at the top. Okay, because I only used two of them in my one identity. Okay, and here I can cancel out, and I'm going to end up with tan theta times sine theta. And I'm really hoping that's what I was supposed to prove. Tan theta times sine theta, yes. Okay, cool. I'm not sure if that was the most effective way of getting there, but it is definitely a way to get there. So no rule was broken. We made it all the way. That looks good. Okay, next question. Immediately I see circular measure. Circular measure, you need to know about triangles and you need to know about sectors. That's pretty much what you need to know. It should be good to go. In the diagram, the triangle ABC. Diagram shows triangle. B is right angle. The length of AB is 8, and the length of BC is 4. Point D on AB is such that that's 5, okay? The sector DAC, okay, so that full sector, is part of a circle with center D. Okay, that's nice to know. Find the perimeter of the shaded region. Okay, so we want to know that plus that. So this is an arc length and a length. Okay, my arc length formula is r times theta. And what I can see here, I can already see I can find L. If I look in my right angle triangle, I can use Pythagoras. So L squared is equal to 4 squared plus 8 squared. What is that? So 4 squared plus 8 squared root. So basically 4 root 5. That's my L. Okay. Now I need to find that theta over there. Let's just have a think about this. I can work out. So in my triangle, if you ever have a triangle, if you've got two pieces of information in a right angle triangle, you can find the rest of it. Okay, so right angle triangle, I can find my alpha. This topic I want to work in radians, okay? So my tan alpha is 4/3. So my alpha must be, okay, just go back to radians. My tan alpha is 0.927295. Okay, I'm just going to write more decimals than not for now. Alright, so if I've got that alpha, then my theta must be pi minus alpha. Okay, so pi minus my answer is 2.21427 radians. My arc length, S is equal to r theta. My radius is 5, and my theta is 2.214297. You probably don't need that many decimals. Anyway, that times 5. It's 11 point, basically 1. 11.1. Okay, and so my total perimeter is 11.1 plus 4 root 5. And that gives me an answer of 20.0. Is it centimeters? Yes. 20.0 centimeters is my final answer. Alright, find the area of the shaded region. Okay, so let me just think about that. That was not bad at all. What I want to just say that you must look out for is look out for right angle triangles and non-right angle triangles. So there's probably other ways to find a lot of information here, but the shortcut would have been to use the right angle triangle. Okay. I don't think that was very complicated though. Okay, find the area of the shaded region. Okay, the area of the shaded region. That is a segment. We don't have the formula for segment, but we can work out the area of the full sector minus the area of the triangle. Okay, so if I just highlight here, we're going to work out the area of the full sector, because we've got a formula for that. Okay, minus the area of the triangle. Let's maybe say that in pink. That's going to give us the area of the segment. Okay, so that's the strategy. I know my area of a sector. So the area of the sector is a half r squared theta. What was that? Oh, a half times 5 squared, 2.214. Okay, so we can already work this out. Okay, that is 27.675 centimeters squared. Okay, and then the area of the triangle. So what type of triangle is this? It is not a right angle triangle. It is a isosceles. Okay, but either way, we can use the sine rule. Okay, so just take note. Take a look at whether you've got a right angle or a non-right angle. If it's right angle, you can use Pythagoras, and you can use SOHCAHTOA, and you can use area is a half base times height. And if it's not right angle, you need to use sine rule, cos rule, or area rule. Okay, my handwriting is terrible, but you get the idea. So it's nice just to order that in your mind. Okay, so the area of the triangle is a half AB sine C, and in this case, it's basically 5 squared, and then the same radius. So a half times 5 squared times sine of 2.214. And you can keep that in radians as well. So our area is basically going to be 27.675 minus 10.002. And that answer is 17.7 centimeters squared. Okay, I don't actually think there's a trick to this one either, so it's quite a nice question. Okay, let's just see know how your attention is going. Mine is fading. Is that some tea? I can't remember what time I was supposed to end. There was 10:30. Okay, so we're doing quite well. What did I say? There's 9, 10, 11. 9, 10, 11. So we've got 3 questions left, and we've only been going for an hour. Well, not even. We've got an hour left. Okay, so we've been going for 50 minutes. Let's keep going. The function f of x is defined by that, and there is a restriction. Find the range. Okay, so this is functions. We need to picture this to understand what's going on. Okay, so functions. All right. My thinking right now is, I don't know. Let me just read the next question. Find an expression for the inverse. Okay. Right, so I'm feeling a bit lazy, but I see that I'm going to have to find the inverse. Okay, let me rather rephrase that. It's difficult to picture. Oh, this is actually not so difficult to picture. I think I will be able to picture this without putting it in completed square format. And actually, in terms of whenever you want to find the inverse of a quadratic, we normally need to find the completed square format, because then you are going to have 1x. My words are failing me. Okay, if you have something like this, ax plus bx plus c, in this format you've got 2 x's, and so when you swap it out, you're going to have 2 y's and 1 x. Then it's difficult to make y the subject of the formula. So generally, we always change it to completed square format, so we have 1x and 1y, so you can swap them when you've got the inverse. Okay, this is a bit of a special question because there's actually not an x term in the middle. Okay, so it's not translated left or right. So what does this thing look like? First of all, I know it's an unhappy face. It's shifted up by 2, and it's stretched. So it's like a skinny, stretched thing. Okay, but the important part here is it's not shifted left or right. So I can actually picture this. Okay, interesting, it is chopped off at -1. So I don't know exactly where that corresponds, but we can work it out. Okay, and they say x must be less than -1. Okay, and so what I do know is that the turning point's at 0. And so I'm going to chop this off. It's going to make it a 1,1 function. Okay, just out of interest. Let me plug in what is my value. So this is -3. Okay, so the picture is not accurate. It would have been basically stretched more than what I thought. So this starts here, something like that. Okay, so my range means y is going to be less than or equal to -1. Okay. Now, as they find the inverse. Okay, we don't need it to be in completed square format because there is only one x. It's kind of in completed square format. Okay, so let y equal to -3x squared plus 2. Alright, so what I'm going to do is I'm also going to write down my x less than or equal to -1. Because now when I swap it, I'm going to say x is equal to -3y squared plus 2. Y must be less than or equal to -1. Now I'm making y the subject of the formula. Okay, x minus 2 divided by -3. Okay, all I see here is a lot of minus signs, so I'm actually going to take out a minus sign. Now if I make y the subject, I square root both sides, so I've got a plus or a minus. Okay, but it's not actually the plus and the minus that I want. So if I'm looking at this, I'm looking at my left arm of my quadratic. So all my values for x are less than 1. So when I flip it, my y values must be less than -1. So basically, I need to choose my sign. My negative sign is going to give me all the values where y is less than. Okay. Alright, I actually don't think there's more to that. Okay, the next question. The function g is notated in that way. That's g, okay. Solve the equation. F of g minus g of f plus 8. Okay, so I'm just going to get my f of x again. I don't remember what it is. So minus 3x squared plus 2. And then x must be less than or equal to -1. Okay, and then g is something else. Right, so this is composite functions. We're putting f into g and then g into f. Other way around, and then plus 8. So we just got to do exactly what they tell us to do here, even though it's weird. Okay, so first of all, I'm putting g into f. So I'll just make a bracket. Okay, so that's my f, and now I'm plugging in g. Okay, minus, and then I need to have g. Let's just make a big bracket. So minus, and then inside g, I'm plugging in f. I'm going to have to really keep my head about me here. Okay, plus 8 equals 0. Alright, so all I can see is don't make mistakes with signs. That's the biggest thing that I've got going on in my mind here. So let's just do one thing at a time. The first thing I'm going to do is I'm going to square this bracket. Okay, so minus x squared is x to the power of 4 minus times a minus is a plus 2x squared plus 1. Okay, and that whole thing is going to then be plus 2. Now, I think what I'm going to do is I'm going to multiply. I'm first going to just multiply in my negative and get different terms here. So I'm going to have minus times a minus becomes a plus. Okay, and then a minus times minus becomes a plus. Right. Now I'm going to multiply my minus 3 in. Now I'm going to square my bracket. Okay, so 9x to the power 4 minus 3 times 2, 6 to 12. Okay, my 1 plus my 8 is 9. Alright, minus 3x4 minus 6x squared. I must be honest, I've sort of lost track of what I'm even doing. Minus 1, I'm solving this equation, plus 9x to the power 4 minus 12x squared plus 4 plus 9. Okay, let's gather all my like terms. So I've got an x to the power 4, x to the power 4. That's ringing bells, by the way. X to the power 4, x to the power 4 is just a format that you need to know. Okay, so minus 3, so 6x to the power 4. Minus 6 minus 12. That's 18x squared. And then 9, 10, 11, 12, 13 minus 1 is 12. Okay, first thing that I can see is I can divide everything by 6. Okay, second thing that I can see is this is a type of quadratic. They love to hide it in the paper, so watch out for it. So basically, you're going to factorize this or use your quadratic formula. That's a 2 and a 1. So x squared minus 2, x squared minus 1. Okay, and the trick is x is equal to minus 1. Okay, is that... Okay, now we just need to figure this out because we've got to put these restrictions on the x. X must be less than or equal to minus 1, and that is true for both functions. So we could say x, sorry, that's a root. Okay, x must be minus root 2. What is minus root 2? It's 1.14. Yeah, 1.14, so that's more negative than minus 1, so that's fine. Minus root 2 or x is equal to minus 1. And that should be your only answers. Okay, cool. So not too difficult. The tricky thing here is making sure all your signs are correct. Okay, and just use big brackets. If you ever need to use big brackets, go for it. If you ever need to take more steps than not, go for it. And then also check your answer. All right. Okay, second last question. Okay, at the point 4 minus 1 on a curve, the gradient is that. Okay, so dy dx, where x is equal to 4, is minus 3 over 2. It is given that dy dx is that, okay, is a constant. Show that the constant is minus 2. All right, so they've given us dy dx. Okay, and that's x minus a half plus k. So now I know when I plug in my 4. So if I plug in 4, my answer should be minus 3 over 2. So k is equal to minus 3 over 2 minus 1 over root 4, which is 2. And so minus 3 minus 4. Okay, so minus 1.5 minus a half is minus 2. Okay, and that's what they needed us to prove. By the way, when you're going through your paper, if they ever tell you to prove something and you get it right, make a symbol for yourself. So tick, tick. You don't have to go back to that to check it. Okay. Find the equation of the curve. All right, so they gave us the derivative. To find the equation, we've got to integrate. And they've also given us a point, so we can plug in a point to solve for C. All right, so we are going to integrate x minus a half, and then k is minus 2. Dx, it's an indefinite one. We're going to be finding an equation. X, we go upper power, divide by the new power. Divide by the new power, it's not the definite integral. We need a c value. Okay, so here that's going to be 2. That's basically root x. Okay, and we're going to plug in the point 4 and minus 1. So minus 1 is equal to 2 times 2 minus 8. 4. 8. My brain is not working. 8 minus 4 is 4, 3. C is equal to 3. So my equation is y is equal to 2 root x minus 2x plus 3. Okay, just check. 2 root x minus 2x plus 3. Great. Okay, find the coordinates of the stationary point. Stationary point dy dx is equal to 0. If I can solve for that, I get the points. Okay, they've already given us our dy dx, which is x to the minus a half minus 2. X to the minus half minus 2. Let's just make it a bit neater. Okay, if I can solve for that, find the coordinates, in other words, the x and y coordinates of the stationary point. So there's only one. Okay, all the keywords in English make sense. Okay. Okay, so 1 over root x is equal to 2. 1 over 2 is equal to root x. Okay, so kind of swap sides there. And so if I squared both sides, it'll be 1 over 4. So my x coordinate is 1 over 4. My y coordinate, I have to go back to this equation. Okay, my handwriting is deteriorating. 1 over 2 minus 1 over 2 is 3. So 1 minus a half plus 3. Oh, yeah. Okay, 3, so that's 4 minus a half, so it's going to be 3.5. Okay, so a quarter and 3.5. It's basically what it's on. Okay, determine the nature of the stationary point. Okay, so we need the second derivative. Okay, you've got to know your theory, by the way. If you don't know your theory, you're going to really struggle. Okay, so find the second derivative, then we test the point. So minus a half x, minus a half minus the 1, it's going to be minus 1.5. And then my 2 falls away. Okay, so that's my derivative, and now I'm plugging in a quarter. Okay, and this is equal to, so it's minus 0.5. I get an answer of -4, so I'm going to have a maximum. Square naught, therefore, no. It's -4 is less than naught, sorry. Therefore, a local max. Okay. We're on our last question. Okay, let's do this. How much time do I have left? Still got quite a bit of time. That's quite cool. All right, this paper, I feel like, I don't know, it's not been too bad. Lots of little things to watch out for, but I feel like they've given quite, I don't know, the questions are not too many marks. And I'm busy saying that as I read. That thing is out of 9. Okay, cool. Let's go. Let's see what we get. So, the diagram shows the curve of x is equal to y squared plus 1. Okay, so they've given it where the subject of the formula is x. That's kind. The points A and B are that and that. They lie on the curve. Find the equation of the line AB. Right, so we've got 2 points. We should be able to find the gradient is going to be, just trying to think. Okay, let's just do this. Change in y over change in x. So 2 minus 1 over 5 minus 2. Always make sure you get the y at the top, the x at the bottom. 2. Okay, so my gradient is 1. Y minus 2 is equal to 1 times x minus -1 is plus 1. X plus 3. Okay, that does not look correct because it doesn't cross at +3. Okay, so let me just double check. The gradient is equal to 1. That's quite likely. Okay, so y minus 2. Oh, do you see what I did? I plugged in the wrong value here. So if I'm using my y value as 2, my x is going to be 5. Okay, hold on. Y minus 2 is equal to x minus 5. Okay, that looks much better. Okay, so always check, does it look like it's right or not? Okay, so y is equal to x minus 3. Okay, find the volume of the revolution. You can leave it in this format, by the way. Okay, find the volume of revolution when the region is rotated about the curve is, okay, basically the shaded region. Find the volume of revolution when the region between the curve and the line is rotated about the y-axis. Okay, interesting. But we can do this. Okay, so what we're going to do is we're going to rotate this region around. So my line is at the top. So I'm going to rotate my line, and then I'm going to subtract, and I'm going to rotate my curve. Okay, so my volume is equal to, I'm going to rotate my line. Oh, I need to make x the subject of the formula. Okay, and that's going between -1 and 2. And then I'm subtracting same boundary, also a pi, and my curve is y squared plus 1. All right, let's go. So keep my pi's. It must also be squared. So here, okay, they did give me an extra page. I'm just checking how much work I need to do. Okay, so here I can use the reverse chain rule because my equation inside is linear. It must always be linear. Right, so I can just say y plus 3, I'm going upper power, divide by the new power, divide by the coefficient of y, which is just 1. Okay, and I'm going between minus 1 and 2. The other thing I can't integrate because it's the inside is not linear. Okay, so that if you're doing the reverse chain rule, your inside must be linear. So I'm not integrating this yet. I have to multiply this out. So y to the power of 4 plus 2y squared plus 1. Okay, right, so now I'm doing like two things at once here, but it's okay. I should actually just do these separately. I think it would make life a lot easier. So I'll just work out the one and then I'll work out the other one. That's a correct then. Okay, here we've got pi. Then I'm plugging in my 2 plus 3 power 3 over 3. And I'm plugging in my over 3. Okay, 2 plus 3 is 5 over 3. 3. 2 to the power 3 is 8 over 3. Okay, so, okay, hold on, this is not 2 to the power 3. 5 to the power of 3 over 3 minus 8 over 3 is just 39 pi. Okay, seems like a really interesting number. Okay, 39 pi. And then I'm going to look at my other integrals. So I know that I'm going to minus this. I'm not going to put it there yet. Okay, so first I had to multiply out. Now I can integrate it. So y goes upper power divided by the new power. Upper power divided by the new power plus y. And we're going between minus 1 and 2. Keep my pi. Okay, to the power 5 over 5. Okay, so I'm just going to say minus 1 because it's an odd power. It's going to be minus 1. Okay, so this is also going to be minus 2 over 3 minus 1. Okay. Okay, so 32 over 5 plus, wait, 2 to the power 3 is 8. Plus 2 is 16 over 3. Okay. Okay. So 32 over 5 plus 16 over 3 plus 2. Okay. Okay, so my answer is 39. Let me just check. 2 to the power 5 divided by 5 3 plus 2. Okay, so 32 over 5 plus 16 over 3 plus 2. Okay. How am I getting here? This is a lot less. Okay, so let me just see, minus 1. Minus 1 over 5. Minus 2 over 3. Minus 1. That should be minus 28 over 15. So this minus times a minus becomes a plus. That's what I didn't do. 206 over 15 plus 28 over 15. Okay, that's 78 over 5 pi. Okay, and so 39 minus that gives us 117 over 5 pi. And that is the correct answer. Okay, so I just needed to double check that. My biggest thing is I didn't do the minus times a minus is a plus. Okay. But that's it. A sneak peek into my brain as I'm doing a PMath 1 paper. I hope it's helpful. It is now 5 to 10. So if I was in an exam, I would now have 35 minutes to check. What I would really encourage you is absolutely check everything. So don't think that you haven't made a mistake. I've had it so many times where I do make mistakes. So just go back and check one thing at a time. As I'm writing my exam, I didn't do too much now. But if you know that it's right, so you have to prove something and you get it right, double tick it for yourself. If you're really unsure or if an answer looks funny, make a star, make 3 stars, give yourself a scale to know what's the most important thing to go back to. All right. But that is me doing a paper late in the evening. I hope that helps. The February-March 2023 paper 1, 2. And that's all for today.